Back to another video, guys. This is all about GCSE, IGCSE. This is a revision for combined questions related to trigonometry. I combine bearings and sine cos rule in one, so I consider the first set. This is part one. Make sure you watch the explanation video for both bearings and sine cos rules. If you're ready to practice, this is the right time for you. Pause the video, try to fix the first problem and also the second one. And let's get started. Okay, so what we're gonna do, we are given a north direction here. Here is the map, and we have three objects. We are given the bearings. Okay, we need to calculate the distance AB. So it's right. We need to calculate distance AC in kilometers if we have the scale. Okay, so the way we're going to accomplish that. So ideally, if you find several angles here, because you have one side AB, that's what are you given, and in order to find AC, you can use sine rule. Okay, so the general strategy is defined, so that's why we just need to look for angles. Okay, so the way we can accomplish that, let's first set up the bearings. Bearings C from A. C from A means we need to put the north direction and set up the first angle. So the first angle is gonna be this one, 120 degrees. Okay, I just write this is 120 degrees, the green one. And we also have the bearings B from A. So B from A, the same north direction, and we measure in clockwise 40 degrees. So here is 40 degrees over there. So that means if we subtract 120 minus 40, we can calculate the angle A. So angle A in degrees is going to be calculated as 120 minus 40. And that means we establish the value as 80 degrees. So inside angle here is 80 degrees. If you like, I can mark it and say that this big angle is just 80 degrees. So we know angle A. Let's move next. We can use the last bearings, C from B. So C from B, what it means, we need to put the north direction right there, okay, through the point B and measure in a clockwise angle, which is 170. It's right there. Okay, so this angle is 170 towards direction BC. Okay, one angle we know, ideally to find AC we need to use angle B, because now we can use sine rule. Okay, sine rule for the triangle ABC tells us that we are looking for AC, so that means side AC to the sine of the angle B is the same as the side, which is AB, 25 centimeters. Right now we calculate it in centimeters, to sine of the angle C. So right now we need to find sine of the angle C and angle B. If we found one angle, let's say B, we can figure out angle C, because simply angle C is angle 180 minus the sum of two rest angles, which is angle 80 degrees, this angle A and angle B. So right now we need to calculate or establish the value for B. How to do that? We have the bearings 170 degrees, so the rest angle is going to be 180, because this is the open angle, minus 170, so that means this part of the angle B is 10. So right now we are going to establish the second part, which is right there. So this is the second part. Okay, so which way we can do that? This angle, if we consider north direction here and north direction there, so those two segments are parallel. So obviously, so that means AB is the second line, so AB is the second line. So that means angle, the second part of the angle B is 40 degrees because it actually using the theorem about alternative angles. So that's 40, the same as this 40. All right, so we established that. So that means angle B together is simply 40 and 10, which is 50. So now we know angle B, it's 50. All right, so we can figure out angle C. All right, angle C is 180 minus 80 plus angle B. We can fix that quick. And it's going to be 130. That means we have also angle B. So that means we have also 50. All right, so first of all, we can use sine rule. That's the first alternative. But because we know that angle B is equal to angle C, this distance is going to be also 25 centimeters. So we can actually skip the sine rule and instead use an isosceles triangle. So because angle B equals to angle C, we have isosceles triangle, and that means lateral sides are going to be the same. So that's why we can immediately figure out AC as 25 centimeters. But if you want to use or see how the sine rule can be applied, so you simply can plug those AC right there and just always squeeze that for a while, and we just simply plug those values inside. But because sine B will be equal to sine C, it will be cancelled, right? Let's have a look. So AC over sine of B, sine of 50, it's going to be the same as 25 to sine 50. Sine 50 will be cancelled. That means AC is 25 centimeters. All right, so what it means that right now we can convert with the factor 2.5 because each centimeter on the map is 2.5 kilometer on the side, means in reality. So that means AC in kilometers, we need to take the value 25 in centimeters and multiply by 2.5 kilometers per each centimeters. Centimeters will be cancelled and we left with kilometers. So that's cancelled and we left with kilometers. So 25 times 2.5, we got 62.5 kilometers. So that's how it goes. Hope you like that. And in the next video, we'll continue with the problem 2. If you had a chance to solve that, share your solution in the comments. Thank you. That was Daniel Dallas, and see you next time.